Welcome back everyone, this is going to be our Unit 6 video on AP CSA. My name is Meek, I'm going to be teaching this class way better than all your teachers can. We're going to be covering things like the array, iterating through arrays, what the heck an array is, what you can store in them, and pretty much how they work. So let's get right into it. So first I want to go over with us what exactly an array is, okay? So think of an array like a list, like a clipboard that contains a bunch of little pieces of paper, okay? Think of it like, where's my pen? Here's my pen. Think of it like this. I got a little line right here, and that line is divided into sections sequentially. Okay? So, and if we count these sections in computer language, this is going to be index 0, 1, 2, 3, and so on and so forth. Okay? So an array is a list like this that stores variables. Okay? So if I, let's say, created an integer and I wanted to store a numeric value into that integer, and let's say I was collecting a bunch of integers. Let's say I was collecting the heights of everyone in my class, okay, to the nearest inch. So maybe one kid in my class is 62 inches tall. Maybe another kid in my class is 70 inches tall. Maybe another kid is 68 inches tall. Maybe another kid is 60 inches tall. Okay? Now, in this particular case, the order of the elements in my array is not particularly important because this is just a collection of the heights of kids in my class. But it is important to me to have them all grouped together on one list. Okay, so I can generalize this in saying that this whole list contains one set of information. It contains heights of the kids in my class. Okay? Now, let's think about this the other way. If instead of putting all of my data into a list, I instead created 9 individual variables and had them swimming around in my code, not necessarily grouped together, then I would need to go out and find the first integer. Then I'd need to go out and find the second variable, then the third variable, then the fourth. I need to call each of them by name, and it's much more difficult, much more time consuming, much more strain on the computer to go out and search for 9 different names of variables, where instead you can just say, hey, look in this list, and that list contains all the data you need. So that's the importance of a list. And now we're going to transition into actually writing the code around one. So first and foremost, we need to create a list. How do we do that? We do it like this, like we would create any other object. First, we specify the type of object, and you would do that as such. If I wanted to create an array that holds integers, I would start the designation like this. Now, an array can only hold one data type. So I can create a double array right beneath it, but I cannot put doubles in my int array and I can't put integers in my double array. So let me continue creating the integer array, which would be the integer designation followed by the name I'm going to assign it. Let's continue with the heights example, equals new int array. Okay. Now what's important here is when I create the array, I need to specify how many things it's going to store. Okay, let's say there are 10 kids in my class, so I need it to have a length 10. I would specify it as such. I cannot change the length of my array after I create it. It will forever have 10 elements in it. Okay? It'll forever have 10 indices. I can't change that. And we are going to get into a different type of array that can change its length in the next video. That's going to be the array list. So maybe I want to create another double array that is heights 1 that is going to store the height of everyone in feet. So I'm going to be introducing some decimal places here, hence the double designation. And there's, again, going to be 10 kids in my class. Okay? So first thing we're going to need to realize is that when we create the array, we created it, but there's nothing inside of it yet. So that means the 10 integer indices, or the 10 double indices, or the 10 string indices, or the 10 turtle object indices will be initialized to their default values. Okay, reminder that the default value for integer is 0, default value for a double is 0.0, default value for a string is, since it's an object, it's going to be null, and for all other objects, going to be null. Okay, a boolean is initialized to false by default. Okay. So now let's start the conversation about how we actually assign values to each position in our array, each position in our list. I use those words interchangeably. So first, what we need to do is we need to refer to the array that we are looking at. And what we're going to do is first we're going to call it by name, then we're going to put these square brackets, and we're going to specify the index that we're trying to modify right here. So let's say I want to put data into the first index. If I switch back to this screen, you'll notice that each data packet, each variable is stored in the list at a particular spot, at a particular index. So I need to specify the index that I'm accessing. First index is going to be 0, as you just saw in the drawing. So I'm modifying the first element in my list, and let's say I want to set that equal to 64 inches. Okay, that's how I would do that. I would assign a particular index like this, and then I could go down the list, and then I could modify index number 1, which is the second index. Let's say that's, guys, 60 inches tall. Now, another thing I could do is in the creation of my array, I could just immediately designate the variables from the beginning. So I would do that by replacing my new int 10 with a open close parentheses, and in there specifying all of the values separated by commas. Okay? And it's much easier, much more simple to specify values this way if your values are known from the beginning. Okay? The reason we can't always specify values like this is because we don't always know what we want to put in our array from the moment we create it. Okay? So we can assign values like this, and now in this code, the integer array initial value, index 0, is going to be reset. It's 60 is going to be deleted, and now 64 is going to be present at index 0. Now 54 is going to get removed, and 60 is going to be present at index 1. So these are not only useful for setting data, these are useful for changing data in your array. Let me add one more height here to get an even distribution. I put one guy is 20 inch. I put two guys are 20 inches tall. Well, let me just do that. So now we're going to start the discussion of how we actually read the data in the array, how we traverse through the data. That's the word we're going to use here in APCSD. We're traversing through a list. Okay, so we do that with loops. And let me first write out the code for it, and then I will demonstrate to you how it works. So this is going to be a little refresher from the loops unit because it's going to be an essential part of your knowledge. Okay, so this is what I've got here. You'll notice that I have my for loop set up right here, and in my parentheses I have my iterating statements. I initialize my increment variable I, my counter variable, I guess you could call it. I initialize that to 0 because I want I to start at 0, and you'll see why when we look at this line of code inside the loop. Then my condition is I want to keep iterating until I reach the length of my array. Okay, I want to continue to iterate through all of the elements until I run out of elements, which occurs when I reach the length of the array. Now you'll notice here that this dot length is not the same dot length that we've used in the past. Okay, when we were dealing with strings, we used the dot length method, which ends in parentheses. All methods end in parentheses. But we're not using the dot length method here. One, because this is not a string, and two, because we're not using a method. Okay? Dot length is an attribute of your array object. Okay, so the way you would access an attribute is the dot operator. Okay, long story short, whenever you want to find the length of an array, you use dot length without parentheses. Let me be very clear on that. All right, and after that, we have my increment variable I being increased by 1 through each iteration of the loop. And during every iteration of the loop, this line of code is executed. We're printing out to the user in the terminal the values stored in our array up here. Okay, so that would be accessed using the name of our array, followed by the square brackets and the index that you would like to reference, the index I, which means at the beginning we're accessing index 0, then I is going to be incremented by 1 and we're going to print out index 1, then I is going to be incremented by 1 and we're going to print out index 2, so on and so forth until we get to index 9. Okay? The length of the array is 10, and we want the last thing to be printed out to be index number 9. Okay? Which is why we are going to stay less than our length. If this was a less than or equal to sign, then the computer would try to print out index number 10, which doesn't exist, and you would get a compile error, and you would get points off your exam. Okay, so let's demonstrate this first and foremost. And you see all the values in my array are neatly printed out here in the terminal. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They're all here. So you'll notice here that I used a for loop. You could use also the while loop. I'll just give you my personal opinion on this. I think the for loop is far superior to the while loop because the for loop puts all my conditions nice and organized here at the top, where the while loop has one condition at the top and you'd have to specify the rest of the conditions elsewhere in your code. So I don't like all of my conditions being spread out throughout the page. I like them all neat and nicely stored right there. It's also a lot easier when you're writing code to just specify your conditions right here and then write your loop. Not, okay, specify one condition here, write some code, then increment the variable here. It's a lot more straightforward to use the for loop, and that's why I think it's the best loop. Okay? Speaking of loops, we have what's called an enhanced for loop that we can use to traverse arrays. The exam calls it the for enhanced for loop. I call it the for each loop, which is the correct name. So a for each loop is demonstrated as such, where you have for followed by your parentheses. So inside your parentheses, you're going to specify the data type that you're going to be iterating through. In this case, we're iterating through an integer array, and that's going to be followed by your temporary variable, and I'll explain all of this in just a moment. Followed by that is going to be your colon, not your semicolon, your colon, and then you're going to specify the thing that you're iterating through, which in this case is going to be my int array heights. So I'm going to specify that identifier right here. And then inside that loop is going to be your loop code. So what's going on here? I am going to iterate through the heights array, and basically how this is read is for each integer in heights, do this. Okay? So if there's 10 integers its heights, it's going to do this 10 times. If there's 4 integers in heights, it's going to do this 4 times. Basically, for each element, execute this. So you see here that I get an error. Why am I getting an error here? Well, it's because I didn't set up my for loop correctly. This is a common mistake that I wanted to show everyone. Okay? So first we're going to explain what the for loop is and what it does, and then we're going to explain why the mistake it was made and how it happened. Okay? So in your for loop, it's going to be read like this. For each integer x in heights, do this, execute this code. Okay? So basically what this is as we're iterating through heights, each integer inside is going to be assigned the value x. Okay, or rather I should say the value inside is going to be assigned to x, where x is the identifier. Okay, so if this is the first iteration through the for each loop, x is going to be 60. Okay, x does not represent the index you are on. X represents the value stored at that index. Okay? And I think you can start to piece together where the mistake happened, where a lot of kids make this mistake. Anyway, let's keep going. So basically, what I'm trying to do here is I am trying to print out the variables one by one. So I want to print out the value stored in my array. And what's the value stored in my array? It's the temporary variable x. So I don't want to print out heights in brackets x. I want to print out the actual value x. Okay? So once I compile it like this, then you'll see my error goes away and I actually reiterate through the array a second time, as demonstrated right here. Okay? An important thing to note about the for each loop is that the for each loop deals with copies of the elements. So what it does is, on the first iteration, it takes the value 60 and it copies it to x. Okay? So if inside my for loop I decide to say x equals x plus 1, if I wanted to increment x by 1, that would increment x, but x is a copy. So if I do x equals x plus 1, this stays 60. This does not become 61 because I am not modifying the actual element. I am modifying a copy of it. Okay? That's another important thing to note. Now, here I'm going to demonstrate the use of an array, demonstrate the use of the for each loop using an example. Let's say on your exam, you are asked to look at an array that contains the heights of the students in your class and then find the average height of students in your class in inches. So the way we would do that is we would, well, you can use any loop you'd like, but I'm trying to demonstrate the use of the for each loop again. We'd set up our for each loop to traverse through heights, and then for each height, we're going to access a total variable that we create outside the for each loop. And say total plus equals x. Okay? And I'm also going to create a counter variable outside my for each loop. I'm also going to initialize that to 0. And in my for each loop, I'm going to increment counter by 1 each time we iterate through. Now, the reason I'm doing that is to allow for expansibility of the code, and you'll see why in just a moment. Then, after the for each loop finishes executing, we are going to put right here system.out.println our average number, which is going to be total divided by counter. And of course, since we don't know if this is going to be a decimal or not, we're going to cast this as a double. Cast it as a double. Okay? Why did I do a counter variable here? Why didn't I just say divided by 10? Because I know there's 10 elements in my array. I did that because maybe I want to iterate through a different array. Maybe I want to use this to iterate through a different number of indices. So it's important when writing your code to make sure that your code is flexible, that you don't hard code anything. Because if I hard coded divide by 10 here, then I would only be able to use this program for arrays which have 10 indices. And I want my code to be flexible. I want to shove an array with 6 indices into it. But that's aside the point. Anywho, you'll see that when I compile this and run, I should realize that I forgot a semicolon somewhere with my demonstration right there. That was unnecessary. And you'll see my average height in my class is 61.7 inches, which is like 5'2". Alright. Again, guys, thanks so much for tuning in. Enjoy life.